Hello guys, in this opportunity we are gonna solve this problem related with rates. A water tank has a shape of an inverted circular cone with base radius 2 meters and height 4 meters. If water is being pumped into the tank at a rate of 2 meters cubed per minute, find the rate at which the water level is rising when the water is 3 meters deep. So, the first step, guys, for solving this problem is sketching the problem. So, but we have it. We have the sketch of the problem already right here. Let's call the variables of the problem be the volume of the cone, r the radius, and h the height. So, and the time t. We know that the tank is being pumped, the water is being pumped into the tank at a rate of 2 meters cubed per minute, right? So we are given that the B, the T is equal to 2 meters cubed per minute. So, and we are asked to find the H, the T, when H is equal to 3 meters. Okay. The quantities V and H are related by the equation V equal to 1/3 of P R squared H. And what is this? This is the volume of the cone. Okay, guys? This is the volume in this case. But if we come back to the sketch, we will see something here. For example, we will see this red triangle with base R and height H. And we will see this blue triangle with base 2 and height 4, right? So we can do something like this. It's very useful expressing V as a function of H, okay? So we want to eliminate in this equation, we want to express only V as a function of H. V as a function of H, okay, in this equation. Well, in order to eliminate the radius r, we can use similar triangles in the figure that we have here. For example, r in the red one, similar triangles, we say r is, or r over h is equal to 2 over 4. We are using similar triangles, so the red triangle is similar to the blue one, so we can express this relationship like this because they are similar triangles. So because we can do that, we can express r dividing h is equal to 2 dividing 4. So we simplify this 2 dividing 4, so we get r dividing h is equal to 1/2, right? This h that is multiplying here, is dividing, sorry, we're gonna send it to the other side of the equation to multiply. That way we get r is equal to h dividing 2. So if we take this equation, we can call this equation number 2, and if we called previously this equation number 1, and we replace equation 2 into 1, then we get v is equal to, remember, 1/3 of p r squared h, but we want to express the volume only as a function of the height. So we replace 2 into 1, so we get 1/3 of p r squared, but r is equal to h dividing 2. So we get 1/3 of p h dividing 2 square multiplying h, and this is equal to 1/3 of p. Okay, h square, 2 square is 4 multiplying h. Then the volume is equal to, we multiply every term at the bottom, so we get p h multiplying h squared is h cubed, 3 multiplying 4 is 12. This is the volume as a function of the height. Okay, guys? So we get this result. We call this number 3. All right? Well, now we can differentiate each side with respect to time, because we want to find how fast the level of the water is rising. Okay, so we differentiate both each side with respect to time. So we get, if we do that, we are gonna do something like this. The v dt is equal to P dividing 12 dH3 dividing dt. Okay, so we get dv dt is equal to P dividing 12. Okay, the derivative of dH3 is 3h dH dt. 3h squared dH dt. Okay, guys? So the derivative of this term, okay, guys, is this. I can simplify this 12 with this 3, and I get P3 simplificated with 12 is 1/4. Okay, h squared dH dt. Okay, guys, so now we get that dv dt is equal to P dividing 4 h squared dH dt. So I'm gonna send this term, this 4, I'm gonna send it to multiply to the other side of the equation, and this P h squared I'm gonna send it to divide. That way I clear this term dH dt, because I want to have that term alone by itself. So dH dt is equal to 4 dividing P h squared dv dt. Okay, guys, so we have but in the problem we want to find dH dt, okay, but in the problem we have if h is equal to 3 meters, dv dt is equal to 2 meters cubed per minute. So we have dH dt is equal to 4 dividing P h squared, but h is 3 meters squared, and the VDT is 2 meters squared per minute. Okay, guys, so we have 4 dividing P, 3 squared is 9, meter squares is meter squares, multiplying 2 meters cubed dividing per minute. Okay, so this meter square simplifies with this meter cube, so we get dH dt. Okay, 2 times 4 is 8, dividing 9p, meters per minute. Is the velocity at which the height of the level of the water is rising when the height, or when when the water is 3 meters deep. Okay guys, hopefully this problem helps you to understand some problems related with application of derivative. See you in the next video. Bye.